Hello all, this is Suresh K. This is my final project, Recurrent Neural Networks for Sequence Data. Coming to the part 1, here I have chosen house property sales dataset. This dataset is a time series analysis dataset. In the time series analysis dataset, we are going to have dependent variables where each variable depends not only on its past values but also has some dependency on other variables. In the visualization below, we can see that the dataset ranges from 2007 to 2019, and this data contains the sales prices for houses with units or apartments consisting of bedrooms ranging from 1 bedroom to 5 bedrooms. In the visualization, we can see the red markings are 5 bedroom apartments or units, and the green ones are 4 bedroom units, and the orange ones are 3 bedroom units, and the blue ones are 2 bedroom units. We can significantly see that the more bedrooms houses which are sold are 4 and 5, which is green color and red color, and the prices have been ranging from 500k to 750k in the median range based on the postal code or the area of the units which are being constructed over there. And this data set has two files, one with 350 data points and other one with 29,580 points. These data points include parameters like prices, date based on the date sold, and the postal codes, and the bedroom units, or the property types, which is units or apartments. Coming to neural networks and RNN. So what is neural network? What is neural network and what is RNN? Neural network is also known as artificial neural networks, and usually their name and structure have been inspired by our human brain and how they pass information to each other, like the neurons. And these neural networks comprises of node layers, which are input layer, hidden layers, and output layers. And each node is activated when they are sending the data to the next layer, means which is sending information to the next layer. Then the next layer is activated based on the information that the input layer or the previous layer has been passed. Coming to recurrent neural networks, recurrent neural networks is a type of artificial neural network which uses sequential or time series data, and usually these algorithms are commonly used for temporal or ordinal problems such as natural language processing, speech recognition, image captioning. Usually these are incorporated by popular applications like Siri, voice search, and Google Translate. So now we have got an idea about neural networks and RNN. Now we are going to go ahead with part 2, which is RNN with sine wave data. And here we can see the previous states, current inputs, and biases, which is a simple RNN structure, which is passed to the sine wave generator. And then the information is passed to the feed forward neural network layer, which then processes the outputs. So now we are building the RNN model. For building the RNN model, we have to import the necessary libraries, which are Matplotlib, NumPy, Pandas, and TensorFlow. The time series modules for TensorFlow, which is dense layer, simple RNN, and also min-max scalar functions. So after importing the modules, we will generate the sine wave. And then after generating the sine wave, we are going to build simple RNN model. Here we are going to take the model as sequential because it is sequential data. And then we are going to add a simple RNN with 100 neurons and the input shape based on the length and the input features. And then we are going to compile the module. And then we are going to train and test the data. Here we are using 80% of the data for training and 20% of the data as testing. After training and testing the model, we'll generate the results and we'll plot it based on the sine wave we have generated previously and the model which we are using for RNN. So here we can see sine wave generated and the predicted wave from the RNN, which are equally similar. So what are the problems with the simple RNN? So the major problems with simple RNN are vanishing gradient problem and exploding gradient problem. So in this slide, we are going to see how these problems have majorly impacted on the model. So usually the vanishing gradient problem arises during the training of the deep neural networks. This gradient represents the direction and magnitude of the steepest ascent of the loss function. The optimization algorithm then uses this gradient information to update the weights, moving them towards a configuration that minimize the loss. This vanishing gradient problem is especially produced when using activation functions like sigmoid or tangent functions. And usually this results in a slow or stalled learning process for those layers, and the network may struggle to generalize and make accurate predictions. So with the help of this problem, this impacts the model's learning progress and learning rate, which diminishes the accuracy. And coming to the exploding gradient problem, the issue arises when gradient undergo repeated multiplication as they traverse the layers during backpropagation. If these multiplicative factors cause the gradients to grow exponentially, they can become extremely large. As a result, the model's parameters may be updated with values that are too extreme, leading to numerical instability during training. This problem is particularly problematic in deep neural networks with many layers, making it challenging for the optimization algorithm to converge to an optimal solution. So these techniques such as gradient clipping, weight normalization, or careful weight initialization are employed to mitigate this problem and stabilize the training process. So the limitations of the simple RNN include short-term memory. These simple RNNs have difficulty learning and retaining information over long sequences. So as this, they cannot capture long-range dependencies in sequences. So these problems has caused, we can see that the predicted wave is not on par with the generated sine wave. So to overcome these problems, LSTM has been implemented. So LSTM is a process with the help of RNNs, which is long short-term memory. And these were introduced to address the vanishing gradient problem and the exploding gradient problem. This LSTMs introduce a cell state, which is a separate memory component that runs parallel to the hidden state. This cell state can carry information across many time steps, allowing the network to retain important information over long sequences. So these LSTMs have gating mechanisms. There are 3 gates: input gate, forget gate, and output gate, which controls the flow of the information. These gates are controlled by sigmoid and tanh activation functions, which help in selectively updating and forgetting information. Here we can see the 3 gates. The forget gate allows the network to discard irrelevant information, addressing the vanishing gradient problem. And it also has a few processes which can improve the significant accuracy of the model with the help of the techniques like gradient clipping, which can be applied to any neural network architecture. It is often used in conjunction with LSTMs. It involves scaling the gradients when they exceed a certain threshold during backpropagation. This will significantly helps preventing the exploding gradient problem. So with the introduction of LSTMs, we can significantly banish all the problems of simple RNNs and it can retain the information for long sequences, which can help the model to gain information and increase the efficiency or accuracy of the model. So now we are going to generate this LSTM with RNNs and time series data. And here we can see in the diagram, we are having two LSTM layers and one dropout layer connected to the input and the output. So this time series prediction is a complex task that demands a carefully crafted neural network architecture, and it involves precise tuning of hyperparameters. In this comprehensive design, we aim to optimize the neural network configuration for time series forecasting based on the provided input. Each aspect of the original design will be revisited and redefined considering the characteristics of the dataset. So coming to the data splitting, here we are going to allocate 80% of the data for training and 20% of the data for testing. These training and testing data splits can be a balanced split, or we can be training and tested based on the time-based split allows network to be tested on the recent data. So we can train and test based on the various factors, and we have to try and test different training and testing data to see which one fits our data set better. So coming to the neuron count, here we are going to have 50 neurons in each LSTM layer. So we can say 100 neurons because we are having two LSTM layers. And then a dropout layer. Usually the dropout layer with a dropout rate of 20% can help preventing overfitting. So with the help of dropout layers, this is also can be training and tested based on the 10 to 30% of the data. So here we are using 20% for the dropout layer.